Hello, my name is Sam. I'm an online maths tutor, and today we're going to be talking about simultaneous equations, specifically quadratic simultaneous equations. Let's go straight into it. So what do I mean by a simultaneous equation? Well, on the screen here I've got a question: solve the simultaneous equations, and then there are two equations written down, one of which is a circle, x squared plus y squared equals 13, and one of which is a line, x equals y minus 5. More commonly, you might see the line written as y equals x plus 5, and that's probably how you would want to draw it, but this is still correct. This is what Desmos has showed me. So what does the question want? Well, what is a simultaneous equation? Well, you're looking for values of x and y which satisfy both of those expressions at the same time. So if I was looking at just the line x equals y minus 5, that outlines the values of y and x which satisfy that line. So that tells me where I can find points on a plane which satisfy that line, which lie on that line. And the same goes with the equation for the circle. So long as your value of x squared and your value of y squared equal 13, your value is on the circle. So these simultaneous equations, when you try and solve them, you're looking for points which satisfy both equations at the same time. Essentially, what that means geometrically is you're looking for these points here. The points on the circle which the line crosses over. That will be your answers or your solutions. If the line does not intersect the circle, there will be no solutions. There will be no real solutions to this question. The simultaneous equations will have no possible real answers for x or y. So how do we solve this? Well, at the moment we've got two equations, and that's not really what we want. We want to only have one equation. And if you studied normal simultaneous equations, this is going to be very similar. It's just going to be a different kind of substitution. You can use elimination here, but I think that substitution is easier because generally your two simultaneous equations will contain one equation which can be very easily substituted into your first equation. So we're going to start here with x squared plus y squared equals 13 and x equals y minus 5. So I'm going to go straight ahead here and put brackets around this y minus 5, and I'm going to substitute my new x, being y minus 5, into my x in the first equation. So I'm going to have y minus 5 squared plus y squared equals 13. I can expand this to be y minus 5 times by y minus 5 plus y squared equals 13. I can expand these double brackets to be y squared. I then get minus 5y minus 5y, so minus 10y. And then minus 5 times minus 5 is plus 25, plus y squared is equal to 13. I can then collect my terms on the left hand side, and I can also subtract the 13. So I'm going to get 2y squared minus 10y, and then 25 minus 13 is 12. So this is going to be plus 12 is equal to 0. And now this is much, much easier to solve. It looks much nicer. We've only got one equation. Even though there are y's here, normally we're dealing with x's and x squared terms. It works exactly the same way. You can still use the quadratic formula, just where you've got y instead of x. And you can still factorize this in much the same way as any other quadratic which you've seen before. And so there is immediately, at first glance, you're thinking, okay, well, two numbers that add to get minus 10 and multiply to get 2 times 12. But actually, since this is an equation equal to 0, and I can factorize something out of all of these three terms, I'm going to do that to make this question simpler. So by factorizing out the 2, I get a much nicer quadratic. And I can divide both sides by 2 to get y squared minus 5y plus 6. 0 over 2 is just 0. So that's going to equal 0. And then we can factorize this like we would any other quadratic. So two numbers which add to get minus 5 and multiply to get 6 is going to be minus 2 and minus 3. So y minus 2 times by y minus 3 is equal to 0. As when we expand this, you get y squared minus 3y minus 2y becomes minus 5y. And minus 2 times minus 3 is positive 6. So then our solutions for y are going to be y equals 2 and y is equal to 3. But this is not enough for your answer. You also need to find out your x terms. So we found this one up here, so this is 3. So we know that y here is equal to 3, which we can see. And we know that y here is equal to 2, which we can see. but we need these x values. We need to somehow get -2 and -3 is our x values from here, and we can simply use this equation given to us at the beginning, x equals y minus 5. So x is going to equal 2 minus 5, which is going to be -3, and then we get x equals y minus 5, so we can use 3, so 3 minus 5, x is equal to -2, and these will be your two answers. Sometimes you can label this with a y1, an x1, a y2 and an x2. This is a subscript, so it's a small number in the bottom right of the letter, and it shows that these are pairs, and these are pairs together, and these will be your correct solutions to this question. Okay, let's move on to our next example. So we have x squared plus y squared equals 34 and x minus y equals 2. So again, this is a circle, x squared plus y squared equals 34, where the radius is the square root of 34, and then you've got a line y equals x minus 2 or x minus y equals 2. So let's start by writing down our first expression. Then we get x minus y equals 2. That's not equal to y, that's minus y. So x minus y is equal to 2. And now I'm going to put the x term on itself. Actually, no, I'll put the y term by itself this time. So this is equal to y equals x minus 2. And I will substitute my y, which is x minus 2, into my y from the first equation. So I get x squared plus y squared, which is x minus 2 squared, is equal to 34. I can expand this bracket here, so x squared plus x squared minus 4x plus 4. Since I'm doing an x times a minus 2 and an x times another minus 2 is minus 4x. And then 2 times by itself is 4, and you've got the double negative, which is a positive. And this is equal to 34. So I can collect my like terms. So 2x squared minus 4x plus 4 equals 34. Subtract 34 from both sides. You get 2x squared minus 4x minus 30 equals 0. Then, much like the last question, you can actually pull something out of both of these, all of these terms. So you can put a 2 out of the 2, the minus 4 and the minus 30. So I'm going to divide the left side by 2 and the right side by 2 to get x squared minus 2x minus 15 equals 0 over 2, which is just 0. Now we're looking for two numbers which add to get minus 2 and multiply to get minus 15. That will be minus 5 and 3. As minus 5 times 3 is minus 15. And then x times by 3 and minus 5 times by x leaves you with a minus 2x equals 0. So my solutions for x are going to be x equals 5 and x equals minus 3. I will use the subscript there as well and put some commas in, and then I will find my y terms. So I know that y equals my x term minus 2, so y1 is going to equal 3, and then x minus 2 on minus 3 gives us y2 is equal to minus 5. And these will be my two answers to our second question. These will also be the coordinates 5, 3 and minus 3, minus 5 that this line intersects with the circle that we started with. Okay, and let's go on to the last example. X squared minus 3y squared equals 13, and 2x plus 3y equals 4. So we've got some different coefficients going on here where we've got some numbers, which is going to complicate things a little bit, but it shouldn't be anything we can't handle. 2x plus 3y equals 4. So I've got 3y squared here, and I've got a 3y on the bottom, but I'm thinking I'm going to have to square whatever's on the bottom, so I'm not really going to do that. Instead, I think it's going to be easiest to substitute in for our x term here. So I need to get what x equals on the bottom. So I know that 2x equals 4 minus 3y, therefore x equals 2 minus 3 over 2y. I can then substitute this back into this circle equation to get 2 minus 3 over 2y squared minus 3y squared equals 13. I can then expand all of this out and see what happens. So because this is a fraction, I will write this out properly. You should do this in your exam to collect all of your marks. 2 times by 2 is 4. 2 times by minus 3 over 2 is minus 3. Minus 3 over 2 times by 2 again is minus 3. And then minus 3 over 2 times by minus 3 over 2 is equal to 9 over 4 y squared. And then subtracting 3y squared to get 13. This is looking slightly more complicated than our previous examples, but do not let these fractions scare you, as we would be able to deal with them in a short while. So let's collect our like terms. So we've got 9 over 4y squared minus 3y. Well, how do we do this in our heads? So we've got 9 over 4 minus 3, and then I can factorise out the y squared. So I'm going to forget about the y squared for now, and I'm just going to calculate this fraction in the middle. So 9 over 4 minus, and then we want the denominator on 3, so this is 3 over 1. We want this to be 4, so I can multiply this by 4, top and bottom by 4, to get 9 minus 12 over 4, all times by y squared, is equal to minus 3 over 4 y squared. So minus 3/4 y squared is what I'm going to have on this left hand side. And that's going to be minus the 6y, since we've got the 3y plus the other 3y. It's going to be minus 6y. And then plus 4 equals 13. Now instead of minusing 13 by here, where I'm going to get 3 negative numbers on the left hand side, I'm going to add the 3/4 y squared, the 6y, and then subtract 4, so I get everything on this right hand side. So I'm going to get 0 is equal to 13 plus 3/4 y squared plus 6y minus 4. I can collect my like terms, and then I'm just going to move the equal 0 to the other side. So I get 3/4 y squared plus 6y, and then 13 minus 4 is 9, so plus 9 equals 0. Now to deal with this fraction, I can multiply everything here by 4. So I will get 3y squared plus 6 times by 4 is 24. And 9 times by 4 is 36. And that is going to be equal to 0. Now what's convenient here is that every one of these terms is divisible by 3. So 3 divided by 3 is 1, 24 divided by 3 is 8, and 36 divided by 3 is 12. So this is going to leave us with y squared plus 8y plus 12 equals 0. Now how do we solve for y? Well, two numbers add to get 8 and multiply to get 12. So add to get 8 and multiply to get 12 is going to be 6 and 2. That's supposed to be an and sign. So 6 times 2 equals 12. 6 plus 2 equals 8. So we can factorise this. So I'm going to move up here to the top to be y plus 6 and y plus 2. So my y values are going to be minus 6 and y is going to be minus 2. I'll put y subscript 1, y subscript 2, and I'll put my commas. So how do I get my x term? Well, our initial equation is slightly more complicated. 2x plus 3y equals 4. So I'm going to write that out here. 2x plus 3y equals 4. And we want an equation which is easily going to tell us what our x term is. So 2x equals 4 minus 3y. X equals 2 minus 3 over 2y. And we're going to do some substitutions of our y values to get this. So our x1 term is going to be equal to 2 minus 3 over 2 times by our y, which is minus 6. It's going to be 2 minus. So our 6 can cancel with our 2 to leave us with a minus 3. Minus 3 times minus 3 is positive 9. So x1 is going to equal 11. And then our x2 term is going to be equal to 2 minus 3 over 2 times by our next y term, which is minus 2. So it's going to be equal to 2. And then the 2 and this 2 cancel. So we get minus 3 times by minus 1, which is plus 3, which is equal to 5. So x2 is equal to 5. So our solutions will be x1 equals 11, x2 equals 5. And these four answers will be the answer to your question. And these will also be the coordinates. So if I do minus 6, 11, and minus 2, 5, these will be the coordinates at which our two original simultaneous equations meet on a graph. Okay, thank you for listening. If you found that helpful, drop a like, comment, subscribe, whatever you want to do. And thank you for watching.